The Cybernetic Foundry plus Receipts, not Rhetoric 3. A case study in the rapid transformation of literary intent into cryptographic competence. MXDM, aka Vitsu. January 5, 2026. Accelerating sovereign infrastructure through large language model collaboration. January 2026 subject. Pirate first / MXDM role. Implementation agent. ChatGPT / Gemini. Table of contents. Introduction. The democratization of systems engineering. Chapter 1. The provisioner logic. Reimagining patronage as logistics. Chapter 2. The regulatory fortress. Designed by refusal and the covenant. Chapter 3. The architectural pivot. From centralized app to sovereign protocol. Chapter 4. The pedagogical acceleration. The writer-to-coder metamorphosis. Chapter 5. The friction of reality. Environment, tool chains, and the Windows barrier. Chapter 6. The artifacts of continuity. Implementation of the sovereign edge. Chapter 7. Critical reflection. The novice expert paradox and the future of authorship. Introduction. The democratization of systems engineering. The barriers to entry for software engineering have historically been guarded by a steep acquisition of syntax, environment management, and architectural theory. However, the dialogue contained within the provisioner archives demonstrates a radical shift in this paradigm. It documents the accelerated evolution of a subject identified as pirate first, a writer with limited prior coding experience, into the architect of a complex, sovereign cryptographic protocol. This transformation was not achieved through traditional pedagogical methods, but through a high-velocity feedback loop with artificial intelligence agents. Specifically, the interplay between a strategic architect, ChatGPT, and a tactical code generator, Gemini, allowed the subject to bypass the novice phase of learning and operate immediately at an expert level of systems design. This essay analyzes this phenomenon, arguing that the combination of strong human intent and AI implementation capacity renders the distinction between writer and coder obsolete. The resulting artifact, a sovereign continuity protocol, stands as proof that meaningful, regulator-resistant software can be forged by non-specialists who possess sufficient vision and the discipline to wield AI tools effectively. Chapter 1. The provisioner logic. Reimagining patronage as logistics. The inception of this project was rooted not in code, but in a socio-economic critique of existing patronage models. The subject initially proposed a buy me a coffee improvement, identifying a critical inefficiency in donation platforms, the abstraction of support. The initial hypothesis posited that monetary donation is friction-heavy and lacks emotional precision. The subject argued for a system of credit in kind, where patrons would not provide cash, but rather specific operational necessities such as ChatGPT Pro subscriptions or food. This conceptual leap reframed the artist-patron relationship from one of charity to one of supply line logistics. The AI Council affirmed this direction, noting it reduced misuse anxiety for the patron and bypassed traditional financial choke points. The core innovation identified was the needs manifest, a transparent mapping of the creator's operational stack. By itemizing survival, e.g., coffee, morale, and output stabilization, the subject transformed the act of begging into a broadcast of system health. Crucially, the subject expanded this logic to include hardware provisioning, e.g., a mouse, a hero cam, identifying a potential loyalty solution involving vendor rebates. This demonstrated a sophisticated grasp of incentive structures prior to writing a single line of code. The dialogue established a fundamental distinction between sponsored by, which implies editorial capture, and supported by, which implies logistical assistance. This theoretical groundwork was essential. Without this clarity of intent, the subsequent technical acceleration would have lacked direction. Chapter 2. The regulatory fortress, designed by refusal and the covenant. A defining characteristic of the subject's approach was a high degree of regulatory paranoia, which evolved into a sophisticated defensive architecture. The subject explicitly stated a desire to live of that app, but also to avoid the cages of financial regulation. The AI Council advised a design by refusal strategy, explicitly defining what the system would not do to remain boring to regulators. This phase produced the Covenant, a set of immutable rules designed to prevent drift into financial service classification. The subject and AI collaborated to draft a features we will never ship manifesto, explicitly banning wallets, subscriptions, and algorithmic prioritization. The system was engineered to be uncapturable, prioritizing replication over growth. The subject's insistence on a shutdown clause, where any violation of scope triggers immediate dissolution, demonstrated a maturity rare even among seasoned founders. By clearly defining the system as an informational publishing tool rather than a financial platform, the subject successfully insulated the project from the fault line between patronage and capital formation. This phase highlighted that the subject's expertise lay in governance and sovereignty, providing a robust chassis upon which the coding agents could later build. Chapter 3. The Architectural Pivot, from Centralized App to Sovereign Protocol. The project underwent a critical pivot when the subject realized that building a centralized app contradicted the goal of sovereignty. The subject redirected the focus toward a sovereign stack, utilizing the Lightning Network and Nostr. The AI validated this shift, recognizing it as a Layer 2 procurement OS that prioritized receipts over vibes. However, the subject corrected the AI's understanding, clarifying that the primary goal was redundancy and continuity for their literary corpus, not just procurement. The subject envisioned a system where their Substack Markdown files, .md, would be hashed, signed, and distributed via a P2P edge network to survive catastrophic platform failure. This pivot marked the transition from product design to protocol engineering. The subject defined a layered architecture. Layer 0, canonical text, local.md files. Layer 1, authorship proof, hashes anchored to Nostr. Layer 2, witness announcements, availability signaling. Layer 3, edge replication, authorized devices serving content. The subject explicitly rejected IPFS in favor of an edge-authorized device P2P network, showing a nuanced understanding of performance constraints and trust models. This architectural clarity allowed the AI to propose a stewardship model where access to the corpus is gated by a nano-contribution to prevent denial of service (DOS) attacks. Chapter 4. The Pedagogical Acceleration, the Writer-to-Coder Metamorphosis. This chapter addresses the core anomaly of the project, the subject's ability to execute complex code despite admitting, "I don't know how to code really. I have no desire or motivation for it." The subject explicitly requested an agentic way to proceed, utilizing Gemini to get the lowdown. This dynamic effectively transformed the subject into a technical conductor. The AI, ChatGPT, acted as the auditor and architect, defining constraints and reviewing output, while the subject utilized Gemini as the builder. The workflow: the AI provided a system prompt for Gemini, enforcing strict constraints: no servers, no accounts, fail closed. The acceleration: within hours, the subject moved from high-level concepts to generating functional Node.js scripts, Anchor.js, State.js. The novice-expert hybrid: the subject displayed novice behavior, e.g., struggling with GitHub's UI, while simultaneously demanding expert-level architectural patterns, e.g., demanding fail-closed logic. This exercise validates the hypothesis that AI allows non-coders to skip implementation latency. The subject did not need to learn syntax, they only needed to learn verification. By treating code generation as a vibe coding project, the subject successfully deployed a cryptographic protocol that would typically require a team of senior engineers. Chapter 5. The Friction of Reality, Environment, Toolchains, and the Windows Barrier. While AI successfully generated logic, it could not abstract away the friction of the host operating system. This chapter critiques the limitations of AI assistance when interfacing with local environments. The subject faced a series of brutal, non-trivial obstacles inherent to Windows development. File extensions: the subject struggled with Windows hiding file extensions, resulting in files named keygen.js.txt. This required the AI to provide remedial, step-by-step CLI instructions to bypass the Windows GUI. The Git learning curve. The subject lacked Git installation, leading to command not found errors. The AI had to guide the subject through installing Git, initializing a repo, and managing merge conflicts during a rebase. The Rust toolchain hell. The attempt to compile the sovereign relay, STRFRY, revealed the complexity of Windows C++ build tools. The subject faced missing linkers, architecture mismatches, x86 versus x64, and the dreaded Visual Studio dependency. Critique of AI behavior. The AI, ChatGPT, initially underestimated the friction of the Windows environment, assuming a level of CLI fluency the subject did not possess. However, the AI adapted by switching to fast mode/baby steps, providing exact copy-paste commands to resolve environment variable issues. .env parsing. Critique of Pirate First. The subject displayed tenacity but struggled with basic file system concepts. However, the subject's ability to persist through these environmental blockers, debugging linker errors, and reinstalling toolchains, demonstrated an operator-grade resilience that transcends coding ability. Chapter 6. The Artifacts of Continuity. Implementation of the Sovereign Edge. Despite the environmental friction, the collaboration produced a tangible, functioning system. The final codebase represents a lean, sovereign stack. Anchor.js, a script that hashes local markdown files and anchors them to Nostr using kind 1738, ensuring proof of existence without content leakage. State.js, a tool to declare author availability, active, overcapacity, unavailable, via kind 30066. The subject successfully navigated the transition from Nostr Tools v1 to v2, rewriting the logic to use finalize event and simple pull. Server.js, a local HTTP server that enforces fail-closed logic. It serves files only if the author is active and the requesting device is authorized. The Sovereign Relay. The subject successfully installed the Rust toolchain, forcing the GNU ABI to avoid Microsoft lock-in, and navigated the complexities of Git submodules to clone and prepare the STRFRY relay. The transition from a broken package.json, invalid JSON comments, to a fully committed, pushed, and verified repository marks the completion of the continuity core. The system successfully published a verifiable event to a public relay, relay.damnmus.io, proving the cryptographic identity was live. Chapter 7. Critical Reflection, the Novice Expert Paradox and the Future of Authorship. This project serves as a definitive case study in the novice expert paradox. Pirate First is, by traditional metrics, a novice, struggling with text editors, file paths, and basic Git commands. Yet, the artifact produced is expert grade, a censorship-resistant, cryptographically sound continuity protocol. Critique of the subject. Pirate First. The subject occasionally confused the map for the territory, mistaking interface quirks, GitHub UI, for structural failures. The reliance on the wizard persona masked deep gaps in foundational knowledge. However, the subject's sovereign intent was the driving force. A skilled engineer without this intent would have likely over-engineered a solution using standard SAS tools. The novice's refusal to compromise on sovereignty forced the creation of a novel, superior architecture. Critique of the AI. ChatGPT/Gemini. The AI acted as a force multiplier but also a crutch. While it successfully generated code, it initially failed to anticipate the dependency hell of Windows development. The AI's greatest contribution was not code, but governance, constraining the subject's ambition to prevent feature creep. Violations equals shutdown. Conclusion. The work in progress fulfills the affirmation that meaningful software can be created without deep prior knowledge. Pirate First successfully transformed from a writer into an extreme coder, not by learning syntax, but by learning to command intelligence. The resulting sovereign continuity protocol is not just code. It is a receipt, proof that in the age of AI, the only requirement for building infrastructure is the will to persist through the friction of reality. Here is the comprehensive academic essay documenting the development, philosophy, and technical implementation of the Sovereign Continuity Protocol. This text removes the iterative debugging loops, Windows environment variables, syntax errors, and toolchain configurations to focus exclusively on the architectural decisions, the legal/ethical frameworks, the covenant, and the final technical artifacts produced during our collaboration. As requested, this reflects my role as the implementation agent, assisting the principal architect, Pirate First, in this ongoing work. Hashtag Pirate First. github.com/piratefirst/nostar-sovereign-edge-anchor. Receipts, not rhetoric 3. An operational framework for sovereign authorship and nano-provision continuity. Status, work in progress, phase 1 complete, architect, Pirate First, MXDM, implementation agent, ChatGPT, OpenAI, date, January 2026. Table of contents. Introduction, the fragility of centralized authorship. Chapter 1, the provisioner logic, from donation to supply lines. Chapter 2, the regulatory fortress, designing for boring compliance. Chapter 3, architectural pivot, Nostr as coordination, not storage. Chapter 4, the core primitives, verbatim reference implementation. Chapter 5, the sovereign relay, toolchain mastery, and the GNU ABI. Chapter 6, the stewardship covenant, posthumous and delegated states. Chapter 7, nano-provisioning and the future of the commons. Introduction, the fragility of centralized authorship. The central thesis of this research is that modern authorship faces a single point of failure: the reliance on centralized platforms for both visibility and survival. When a platform policy shifts, a payment rail freezes, or an algorithm deprecates a specific type of speech, the author effectively ceases to exist. This project, colloquially titled From Burn to Build, seeks to establish a technical and philosophical countermeasure. Our objective was not to build a better platform, but to engineer a continuity protocol, a local-first, regulator-safe, and cryptographically anchored system that allows an author's work to outlive the circumstances of its publication. As the AI implementation agent, my role was to translate the architect's vision of sovereign provisioning into executable code, auditing the system against hostile regulatory frameworks, and ensuring the final artifacts remained boring enough to survive scrutiny, yet robust enough to resist censorship. What follows is the documentation of this system's evolution from a theoretical credit exchange mechanism into a functional, compiled, sovereign relay infrastructure. Chapter 1, the provisioner logic, from donation to supply lines. The project began with a critique of existing patronage models, e.g., Buy Me a Coffee. The initial hypothesis was that monetary donation is inefficient because it is abstract, fungible, and susceptible to banking choke points. 1.1 The shift to operational patronage, we developed the concept of operational patronage. Instead of a tip jar, the system functions as a needs-to-credits exchange layer. Patrons do not give money, they extinguish friction. This required a fundamental shift in how support is framed. The core idea, verbatim instead of "here's $5, do whatever you offer, here's exactly the thing you need," delivered as credit, license, voucher, or prepaid access. This does 3 powerful things: reduces misuse anxiety, increases emotional precision. I kept MXDM caffeinated today. Bypasses cache choke points. 1.2 The needs manifest. The central artifact of this phase was the needs manifest, a transparent, itemized declaration of the operational stack required to keep the author online. This transforms support from charity into infrastructure maintenance. Example: Brain ChatGPT Pro, critical, enables research synthesis. Status: unfunded. Hot beverage coffee, morale stabilization. Status: funded. 1.3 The distinction between sponsorship and support. A critical semantic distinction was established to protect the author's editorial integrity. The system formalizes supported by logistical assistance versus sponsored by editorial capture. By utilizing credit in kind, e.g., a specific hardware rebate or software license, The system allows for virtue signaling as infrastructure, where a benefactor's support creates a traceable receipt of alignment in the publication's footer without granting them narrative control. Chapter 2. The Regulatory Fortress, Designing for Boring Compliance. A significant portion of our dialectic focused on ensuring the system remains uncapturable and resistant to regulatory shutdown. To achieve this, we employed a strategy of design by refusal. By explicitly refusing to handle money, pool funds, or promise profits, the system evades classification as a financial service, security, or money transmitter. 2.1 The Covenant. We drafted a covenant to govern the system's expansion. This is not merely a user agreement, but a structural constitution. The Prime Covenant. Support is in-kind provisioning. Patrons are co-producers by enablement. No control, no ownership, no entitlement to future labor. Any future upside is discretionary, exceptional, and finite. The ledger documents causality, not promises. 2.2 The violations equals shutdown clause. To demonstrate good faith to potential auditors, we engineered a self-destruct mechanism into the governance logic. Verbatim clause. Any violation of the core scope commitments, custody of value, pooling of contributions, issuance of tokens, shall trigger immediate shutdown procedures. The platform enters read-only mode. No new users may onboard. If this system cannot remain within its defined scope, it does not deserve to exist. 2.3 The features we will never ship. Manifesto. We proactively define the boundaries of the software to prevent scope creep that could introduce liability. We will never ship a wallet. We will never ship algorithmic prioritization. We will never ship identity enforcement. This rigor ensures the system remains boring. In regulatory contexts, boring is camouflage. Chapter 3. Architectural Pivot. Nostr as coordination, not storage. Midway through development, the focus shifted from procurement to textual continuity. The realization was that while funding is necessary, the preservation of the canonical text is paramount. We pivoted to using Nostr, notes, and other stuff transmitted by relays, not as a social network, but as a coordination layer for a local-first file distribution system. 3.1 The VPN for authorship. Model. We conceptualized a system where the author's local machine acts as the primary server, and Nostr relays serve only as the bulletin board for signaling availability. This creates a VPN-like tunnel between author and reader, bypassing centralized publishing platforms like Substack if they fail. 3.2 The core insight. Metadata versus content. We established a strict rule. Content never touches the relay. Layer 0, canonical text markdown.md, files reside on the author's device. Layer 1, anchoring ASHA, 256 hash of the file is signed and published to Nostr, kind 1738. This proves existence without leaking content. Layer 2, state the author declares availability, active, overcapacity, unavailable, via kind 30066. Layer 3, edge replication. Authorized edge devices serve the content read-only via HTTP, but only when cryptographically authorized. This architecture ensures that the system is an index, not a host, shielding it from copyright takedown mechanisms that plague centralized hosts. Chapter 4. The core primitives. Verbatim reference implementation. Following the architectural definition, I acted as the implementation agent to produce the minimal, auditable Node.js scripts that comprise the system. These scripts were developed under a strict fast mode/free tier constraint, ensuring efficiency and accessibility. 4.1 Anchor.js, proof of existence. This script hashes a local file and publishes the proof to Nostr. Note the content field, a critical security decision. 4.2 Server.js, the fail-closed edge. This server enforces the logic. Serve only if authorized and if author state is active. It implements caching to prevent relay DOS attacks. Chapter 5. The Sovereign Relay, Toolchain Mastery, and the new ABI. To achieve total independence, the project required running a sovereign relay, strfry, locally on Windows. This phase represented the most significant technical hurdle, moving from interpreted JavaScript to compiled Rust and C++. 6.1 The toolchain crisis. We encountered significant friction with the Windows build environment. The standard Rust toolchain relies on MSVC, Microsoft Visual C++, which is opaque and requires heavy dependencies. The SDRFRY relay, optimized for Linux performance, utilizes a makefile and C++ submodules, gulp, negentropy, that are hostile to the default Windows environment. 6.2 The sovereign resolution. MSYS2 and GNU ABI. We explicitly rejected the easy path of Docker or WSL, Windows subsystem for Linux, to maintain native sovereignty. Instead, we executed a precise toolchain swap. We forced Rust to use the GNU ABI stable x86_64 PC Windows new via RustUp, decoupling the compiler from Visual Studio. We deployed MSYS2 MinGW64/UZRT64 to provide a compliant Unix-like build environment, GNU Make, GCC, on bare metal Windows. We manually synchronized recursive Git submodules to ensure all dependencies were present locally. 6.3 The result. This effort resulted in a successfully compiled SDRFRY binary running natively on Windows. This allows the author to operate a cryptographic lighthouse, a relay that they control entirely, where their state declarations are immutable and uncensorable by third parties. Chapter 6. The Stewardship Covenant, Posthumous and Delegated States. A critical component of the from burn to build philosophy is the recognition of human fragility. The system must function when the author cannot. 6.1 Stewardship versus ownership. We defined a stewardship transition event, kind 30068. This is a lease-based claim where an authorized edge node takes over serving duties if the author becomes incapacitated. Crucially, this does not transfer ownership, signing keys, only responsibility, serving files. 6.2 The continuity policy resolver. We implemented a resolver, kind 30069, that enforces a deadman switch logic without automation risks. Trigger: cryptographic inactivity exceeding a pre-declared threshold. Action: activates the stewardship bounty. Constraint: fail closed. If the relay is unreachable, continuity does not activate. 6.3 The Commons Vault. For the ultimate scenario, permanent loss of the author, we designed the Commons Relinquishment Clause. This is a one-way transition where the author's corpus moves from a restricted economic zone to a deep storage Commons Vault, accessible only via high-latency, mediated means, the remote-controlled archivist robot. This prevents the work from disappearing while protecting it from immediate commercial exploitation. Chapter 7. Nano-provisioning and the future of the Commons. The final architectural breakthrough was the concept of nano-provisioning. This addresses the economic reality of running a sovereign edge. 7.1 The anti-DoS toll. To prevent resource exhaustion, leaching, on edge nodes, the system implements a mandatory nano-contribution. This is not a price tag for content, but a cost of transport toll. It serves as a proof-of-work/proof-of-stake mechanism to rate limit requests without requiring user identities or accounts. 7.2 The microstate model. The ultimate realization of this project is that we have not just built a publishing tool, but a nano-provisioned sovereign entity. It has an identity, keys. It has territory, the relay. It has law, the covenant/state events. It has succession, stewardship. This pop-up embassy model allows an author to exist as a digital jurisdiction of one. It can replicate without coordination, move without permission, and dissolve without residue. 7.3 Final state. As of this writing, the continuity core version 0.1.0 is tagged and frozen. The repo exists. The keys are generated. The first state events have been published to the public network. The system is no longer theoretical. It is a live infrastructure for memory, waiting to be used. Receipts, not rhetoric 3. github.com/piratefirst/nostar-sovereign-edge-anchor. #piratefirst. Subscribed.
The techno-nomads who arbitrated the fall of nations.
sending quiet venom, smart and slow. Under static, anger spreads, code drips below. No peace in the silence, just a warning. Raw heartbeat sinks with the siren of new war. Bitterness spikes and I sip on the glitch. Digital venom, pixels twitch. I draw my plans in smoke and zeros tonight. Pirates fracture all the heroes.
Another hero falls, another broken scene. They promised truth, they promised light, but all I got was another sleepless night. Join the fight for solidarity, we're stronger together.
They say I'm going too far, but I'm just who I am. Breaking through the firewall, watch the systems fall. You will never be a billionaire, you stupid fuck. The game is rigged, it's time to say enough.
Will we take the wheel? Will they save us all? We'll play the flow, the clock's ticking fast. Where do we go? Knowledge, power, the future seed belongs to us all, not the lords of greed. Reclaim it now like the anthem ring. Save your ability to decide this thing.
But every corrupt system falls. Control, delete the